Okay, before watching today's videos, be sure and download the worksheet that goes along with it, because we're going to be working together on these today. And so today is just kind of an overview of everything that we've learned in 0300 and 0301 and how you're going to use it when you move into college algebra. I think when I've worked with people in tutordom, the hardest thing they have is knowing where to start and what to do, because when you look at all these equations, they look all very similar and they just don't really know where to start. So this is going to be kind of like a little cheat sheet and a note sheet for you to take farther along with you. So these will help you in calculus, college algebra, whatever math classes you have where you have to solve equations. These methods will help for everything. So the back sheet is kind of just like a note sheet of everything that we've talked about so far. So back in 0300, it was really important to learn the steps for solving equations. And so these are for linear equations. And so linear just means to the first power. So anything where x is to the first power, you're going to solve it by linear. And we've talked about these steps in 0300, where the first thing you always want to do is clear your fractions or decimals, then get rid of your parentheses, be aware of your equal sign and simplify each side, move letter to left, number right, divide by the coefficient. So this is what we spent a lot of time on in 0300. Then we moved into, and we learned how to factor. I'm sorry, we did this in 0300 and 0301. And so before you can solve quadratics, you have to be able to factor. So the ways we've learned this semester for solving quadratics is either factor it, the quadratic equation, the square root property, or completing the square. So linear equations of the first power, you'll always use these 6 steps. Anything with a 2 or above, you're going to look at these steps to solve. And so these we've worked through all in this chapter. So let's put that all together with some examples. And so work along with me on these just so you'll have a completed note sheet that will help you in the future with any problems that you might have. I'll move this down a little bit. Okay, so let's first look at number 1. Now 1, 2, and 3 are all linear equations because do you see all the x's? Anywhere you see an x, it's just to the first power. So for a linear equation, we're going to use our 6 steps for solving equations. And so step 1 is, does it have any fractions? No. Step 2 is, get rid of your parentheses. So we're going to distribute here and make this a 10x plus 15 minus 4x equals 2x plus 25. So work along these along with me so that you'll have a corrected worksheet to take with you in the future. So we got rid of our parentheses. Then step 3 is be aware of the equal sign. It's right here. And move simplify each side. So on this side, you see that it can do a 10x minus a 4x is a 6x. So I have 6x plus 15 equals 2x plus 25. Then step 4 is move your letter to the left, and when you go over the equal, you do the opposite. So we're going to minus a 2x and get 4x plus 15 equals 25. Move your number to the right, so I'm going to minus a 15 and get 4x equals 10. And then divide by the number in front, step 6. So x is going to equal 10/4, but just remember in all of algebra, all of mathematics, you always want to leave fractions in simplest form. So that would reduce to be a 5/2. So this again is just a review from 0300, but important that you know these things going forward into college algebra. This next one, we see decimals, and a lot of people want to just skip it because it looks so difficult. But remember, in our steps for solving equation is to get rid of your decimal in the first step by moving all of them the same amount of numbers. Do you see this plus 2 needs one place? 0.5 needs one place, 0.1 needs one place, and the anything in parentheses is always ignored. It's like they're protected from that. So this 0.2 can become a regular 2 times 60. The 0.5 can become a regular 5x, and the 0.1 can just become a 1. So once you get rid of those decimals, it looks so much easier. So step 1, we got rid of our decimals. Step 2, we're going to get rid of our parentheses, so we're going to multiply here and we're going to distribute here. So this is 120 plus 5x equals 60 plus x. Then we want to move our letter to the left. So this is like a minus 1x. Bring everything else down. Then move your number to the right. And then step 6, divide by the number in front. So x equals a negative 15. So you notice with linear equations, 1x has one answer. 1x has one answer. Let's look at the last one, which is fractions, which is the one most people like to skip. But just get rid of those fractions in the first step by multiplying by the LCD, or the least common denominator. So you look at all your denominators, 4, 2, and 4, and my LCD is going to be 4. If you don't remember which one it is, it's the first multiple. So 2, the multiples of 2 would be 2 and 4. So 4 is the multiple they all have in common. So we're going to multiply every single thing, not forgetting this 4 right here, by 4. So you multiply every single term by 4. Then you multiply and divide. So 4 times 1 is 4. Divided by 4 just leaves a 1x there, or you can cross cancel, which is the easier way there. And then minus 4 times 4 is 16 equals. Here though, you've got 3 times 4 is 12. Divided by 2 is 6. And then here you've got 12 divided by 4 is 3x. So we got rid of our fractions on the first step, and now we can follow our other 6 steps. So step 2, get rid of parentheses, there's not any. Step 3, be aware of your equal sign and combine like terms. I can combine both of those, making that a 9x. Step 4, move your letter to the left. Again, I'm going by the steps. There's always shortcuts to every problem. So this one you could have done it shorter if you moved your number first, but we're going to go by the steps. So step 4, move your letter to the left. Step 5, move your number to the right. And so negative 8x equals 16. And then step 6, divide by the number in front of the letter. So x equals negative 2. So solving linear equations, those are the 3 types that will come up. Just know with decimals and fractions, you can get rid of the decimal or fraction by either moving the decimal place or multiplying by the least common denominator. Okay, so now let's look at quadratics. Those are all anything with 2 or higher. Now in this class, we really only deal with 2, but I'm going to talk about higher here in a minute. But see, all of these are to the second power. So that means they have 2 answers. And so the easiest way to do these, and the way you always want to try first, is to see if you can factor it. So this one, we can read it backwards and say factors of 15 that add to be 8 would be 3 times 5. So we just factor it into largest, smallest, x and x. First sign comes down. The last sign tells you the signs are alike. And so it's the same as the first one, and that equals 0. If you're still having trouble on factoring, remember the YouTube videos 5.1 or 5.4 go through all these in detail. And now, once it's factored, you know your answers or your zeros by the opposites of these. So x is going to equal a positive 5, and x is going to equal a positive 3. To the second power had 2 answers. To the first power had 1 answer. So if you can factor it, that's the quickest, easiest way. So let's look at number 5 and see if this one will factor. I actually haven't worked these out before, so I don't know for sure if they are, but the way to check if there's a number out front, you want to see if you can factor it out. If you can't, then let's try to factor it by doing the multiply, divide, reduce. So here, 8 times 3 is 24, and I want factors of 24 that add to be 14. So that would be 2 times 12. So this one will factor. So we go to our parentheses, largest, smallest, W, W, first sign comes down. Addition says they're alike. Because we multiplied 8, we divide by 8. So and then reduce those fractions. So here 4 would go into both of them, leaving a 3/2. And here 2 would go into both of them, leaving a 1/4. And with an equation, you don't have to move the numbers to the front like we did before, because we can get our answers straight from the zeros of this equation. So here, W would equal a positive 3/2, W would equal a positive 1/4. So both of those are from chapter 5. And you can go back and watch the videos on those if you want to. So if you can factor, factoring is the easiest way to go around. But let's look at this next one. I don't know that it might factor, but I don't think it will. But in order to see if it'll factor, I'm going to move my 1 over, make that a plus 1 equals 0. And then if you look at 2 times 1 is 2. There's not any factors of 2 that add to be 4, so it won't factor. So you can either, so you want to think of 3 different ways. Quadratic equation, completing the square, or the square root property. The square root property is not going to help us on this one because it's not in square root form. But for this one, here's how I look at it. If there's a number in front of the x squared, then the completing the square is a much harder form because you're going to have to divide everything by 2, which is going to leave you a fraction, and yada, yada, yada. So if it's got a coefficient in front and it won't factor, my opinion is that the quadratic equation is the easiest form because you can just count that as an A, that as a B, and that as a C. So let's do quadratic equation on this one. So A is 2, B is 4, and C is 1. And we're going to plug it in that equation, negative B, so negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 2. So then x is going to equal negative 4 plus or minus. Let's look at the square root here. So 4 squared is 16. There's only 1 minus, so that's going to leave us a negative, and 4 times 2 is 8. 16 minus 8 is 8. The square root of 8 breaks up to be the square root of 4 times the square root of 2, or 2 square roots of 2. So that entire square root became 2 square roots of 2, and then the bottom's going to be 2 times 2 is 4. Then remember about your triangle there. So your final answer, since all of those can be divided by 2, is going to be a negative 2 plus or minus the square root of 2 over 2. So if you can't factor it, then you decide which one do I want to use. Quadratic equation will always work, but you see it takes a lot of work. I'm going to do the completing the square on this one and show you the difference. But because this 2 was in front of there, completing the square only works in the form of the x being having no coefficient. If it has a coefficient, you've got to divide to get rid of it. So in my opinion, if there's a number out front, do quadratic equation. Let's look at number 7. Now you can do quadratic equation. You'll get the right answer, and that's perfectly okay. Now on your test, I make you do one of each type, so read the directions on your test. But going forward in college algebra, you can solve these any way that you want to. So my first thought would be to move the 4 over, and are there factors of 4 that add to be 8? No, so I can't factor it, because if you want to factor it, you see how much quicker it is to factor than to do the quadratic equation. I can't factor it. I could do the quadratic equation, but I just want to do a completing the square just so you'll see and remember how to do this. So to complete the square, you're going to leave a blank on this side. The 4 is already on the other side, so I don't have to move it, and a blank on the other side. Then you look to this middle term 8, and you take half and square it. Again, all of the directions are here on the note sheet for completing the square. So this half of 8 is 4. 4 squared is 16. So I'm putting a 16 in both of those. Then you factor this to be x minus 4 squared. Again, there's a full video on this for you to watch. I think that's what, 11.2, I think. And then negative 4 plus 16 is 12. Then we do the square root property, which is to square root both of these. So I get x minus 4 equals plus or minus the square root of 12. But I need to simplify the square root of 12 to be the square root of 4 times the square root of 3, or plus or minus 2 square roots of 3. And then I need to move the 4 over, so my final answer is x equals 4 plus or minus 2 square roots of 3. And so if you complete the square, it's so much less trouble than all this going on over there. But again, if there's a coefficient in front, you can't complete the square on that one without having fractions, and nobody likes to mess with fractions. Okay, then these last two, you could use quadratic equation again, but why when this is just an easy square root property? Because x squared minus 20, because 20 is not a perfect square. If it was x squared minus 36 equals 0, then it's easy to factor because it's just x minus 6x plus 6. I don't want you to think that's part of the work, but this is not a perfect square, so we can't, it's not a difference of two perfect squares, so we use the square root property. And to do that, I'm going to move my 20 over and get x squared equals 20. And then remember, if you have your x squared by itself, you can square root both sides. So x equals plus or minus the square root of 20. Remember, when you use the square root property, you got to do the plus or the minus, and that's why we have those in all of these. Because again, we needed two answers for this one. So the answer is 4 plus 2 square roots of 3 and 4 minus 2 square roots of 3. It's two different answers. And then we do need to simplify here. Square root of 4 times square root of 5. So x equals plus or minus 2 square roots of 5. So we solved that one by the square root property. Now this next one is a parentheses squared. Now you could FOIL that out, move your 25 over with your 0 on the other side, plug it in the quadratic equation. It might factor. Any of those things you could do, but that's so much more work. Because this parentheses squared is all by itself, you can do the opposite, which is just to square root both sides. So this gives you x minus 3 equals plus or minus 5. So as soon as I did that, I know this one would have factored. If you multiplied all that out and factored it, it would have worked. But for square root property, then we move our 3 over, so we end up with x equals 3 plus or minus 5. Now, if you have square roots, you can leave it in that form, but if you have whole numbers, you need to go ahead and add them and say 3 plus 5 is 8, so that's one of my answers, and 3 minus 5 is negative 2, so I've got my two answers. So that's a good review for this next test. You'll have some like all of those on there. Okay, but let's look a little forward going into college algebra and just thinking about when you see something and it throws you off, what do? You always want to do the opposite. So I've got on here that if other equations don't fit into the above, just think to yourself, whatever's holding me up, I want to do the opposite of. So let's look at this first one, number 10, square root of x equals 5. Well, that square root of x is throwing me off. Well, what's the opposite of a square root is a squared. So to solve this, you can just square both sides and get x equals 25. So I want you to always think of doing the opposite. To get rid of a square root, you square it. Let's look at this next one, a cube root. X to the third. What are you going to do to something to the third power? You're going to take the cube root. So again, you would just cube root both of these and get x equals 2, because 2 times 2 times 2 is 8. Again, we're just kind of using some common sense here. To get rid of the square root of this, you square both sides. Now, you do have to have the square root by itself, but it is by itself. So you square that, and you're going to have x minus 2 equals 9 squared is 81. Then you can just solve it, because now it's a linear equation. So x is going to equal 83. 13 is a cube root. So what are you going to do to get rid of a cube is, a cube root is cube it. So this would be x minus 1 equals 2 cubed is 8. Add the 1, so x equals 9. So you always want to get rid of that thing that's bothering you by doing the opposite or undoing it. This last one is a fraction. Oh, we hate fractions, right? But we look at the denominators, and you want to get rid of the denominators. So whatever the bigger exponent is, you want to get rid of this x squared. We're going to multiply everything by x squared. Because anything you want to get rid of as far as fraction form, you get rid of it by multiplying everything on the top by it. So this is going to leave me an x squared minus a 1x minus a 28 equals 0. And now You see if you can factor it. I don't know if you can, so let's see. We want factors of 28 that subtract to be 1. So 1 times 28, 2 times 14, 3 times, doesn't work, 4 times 6. So that won't factor, will it? I'm sorry, I'm trying to think here because I thought it would factor, but I don't think it will. So it won't factor, so now let's use our other forms. We can either complete the square, or we can, complete the square or quadratic equation. So so here's why I wouldn't do completing the square. If you completed the square, you'd have to take half of 1 is 1/2. 1/2 squared is 1/4. It's perfectly okay. You can work it out and get the right answer. But why do we really want to have to mess with that? So let's do quadratic equation. So my A is going to be 1, my B is going to be -1, and my C is going to be -28. And plug it in. So X is going to equal a negative B. A negative of a -1 is a +1, plus or minus the square root of -1 squared minus 4 times 1 times -8 all over 2 times 1. So I first tried to see if it factored, it wouldn't. So then I'm going to go to quadratic equation. So again, we got to look at this square root. So the square root of -1 squared is 1. 2 negatives make a positive. And so 28 times 4 is 112. Should have worked some of these out before, but that's all right. That's what real life. And so that becomes the square root of 113. So we're going to plug that back in. So X would equal 1 plus or minus the square root of 113 over 2. And so those are all the different types of equations you might have to solve in college algebra. We didn't go over these in depth. I might throw 1 or 2 on the test just to see if you're thinking through them. I won't give you any hard ones though. But just whatever roadblock you see or whatever thing you see that you don't really understand, just do the opposite of it. So good luck in college algebra, guys.